Example number 3, we're given some Cartesian equations and we're asked to find some relationships and stuff. Actually, we'll just put the picture of the book up here. For example number 3, we have like 4 equations. And what they want us to do is says, which of the graphs are relations that are functions, and which relations have inverses that are functions? So the first thing we need to do is figure out what's a function. Well, who remembers how we could figure out what a function is by the graph? Does anybody in here remember how to do that? It's called the vertical line test. The vertical line test is simple. I take a vertical line and I just go through the entire equation. So this pencil is like a vertical line. Actually, it's too thick of a vertical line. We'll use my paper clips. Yeah. So if the paper clip is a vertical line, how many times does that intersect the curve? Only one time. And no matter where I go, now this is a funky function because right here we have a vertical asymptote, but anywhere on the domain as it is defined, how many times does that paper clip cross the curve? Only one time. Notice that we have function written down. That's a vertical line test. Now when we get to this one, how many times does it cross the curve? Twice. Is that a function? No, it is not a function, so it failed the vertical line test. What about this one? How many times does it cross the curve? Twice. Is that a function? No. So it failed the vertical line test. What about this one? Well, we have a vertical asymptote right here, but if it doesn't matter about the vertical asymptote, how many times does it cross the curve? Only one time, so that is a function. So first thing we were supposed to do was figure out what they are. And so this is a function, only crosses once. Not a function, crosses more than once. Not a function, the vertical test failed. Function. All based on the vertical line test. Whenever I go through, how many times does it cross? Okay? That's how that works. Now, to figure out if it has an inverse function, now they all have inverse relations, but to figure out if the inverse relation is a function, we do the horizontal line test, which is the exact same thing as the vertical line test. It's just one means that the graph is a function, the other test means that the inverse is a function. So we do the exact same thing. How many times does this cross the curve if I do a horizontal line? Only one time. Again, we have a horizontal asymptote at y equals 0, but if you look, it only crosses the curve one time. Now here's what's interesting. On this graph, how many times does it cross the curve? Well, if I keep a vertical line and I keep my vertical line straight, even though there's a horizontal asymptote here, but it only crosses the curve one time. Okay? So this one has an inverse that is a function. Is that weird? So this is not a function, but its inverse is a function. Now this one, my ellipse, well, that fails the horizontal line test as well. So this has an inverse, but the inverse is not a function. And this one right here, we're good until we get to here. How many times does that cross the curve? Twice. So what does that mean? the inverse is not a function. Does that make sense? That's it. That's all we have to do for example number 3. So when you enter in a graph, the vertical line test determines if the original function, or if the original mathematical relationship is a function. The horizontal line test determines if the inverse relationship is a function. Okay?